Consider all rectangles such that the rectangle's length is greater than the rectangle's width, and the length and width are whole numbers of inches. Which of the following perimeters in inches is not possible for such a rectangle with an area of 144 square inches? So, the great news about these not questions is that there's a pretty useful hack. It's almost always going to be the largest or the smallest answer in these scenarios. And so, a great way to approach them is just to come up with the biggest perimeter you can come up with and the smallest perimeter. And there's a hack to this as well. To be able to get the largest perimeter, you want the length and the width to be as far apart as possible. That's going to give you the largest possible perimeter. And then when the length and the width are as close together as possible, that's going to give you the smallest perimeter possible. So we're going to find the largest and the smallest, and that will likely give us our answer. So we'll start with the largest, which, since they have to be whole numbers, we'll do 144 for the length and then 1 for the width. When you multiply those together, it's going to come out to 144. And then when we do 2 times each, we get 288 plus 2, which is 290. And there is no answer that is bigger than 290. So that's not going to help us. So we're going to go to the smallest possible perimeter. And we can multiply 12 times 12, even though that's not a possible option because the length must be longer than the width. But therefore, that means any other option is going to be bigger than this. So if we have 12 times 12, then the perimeter is going to be 24 plus 24, which is 48. And that is actually an answer, which we know this can't be the answer because in this scenario, the length and the width are the same, and it tells us the length must be greater than the width. Therefore, we know that answer A is correct because it can't be answer A.